All right, let's just jump right in. When you think about the universe, you picture stars, galaxies, all the planets, everything we can see. But what if I told you that all of that stuff, everything we've ever studied or even looked at, is barely a footnote in the story of the cosmos?
Take a look at this. This is essentially the recipe for our universe, and it's shocking. Everything we know, what scientists call normal matter, that's less than 5% of, well, everything. About a quarter of the universe is this mysterious thing called dark matter. And then you have this whopping 70%, the vast majority, which is an even stranger force called dark energy.
Just let that sink in for a second. Our entire existence, all of human history, all of our science, it is all played out in what amounts to a tiny, tiny sliver of what's actually out there. And here's the real kicker. It's not just that this other stuff exists, it's that we have almost no idea what it is. We can see what it does, we can measure its effects, but the stuff itself, we're almost completely in the dark. So let's try to shed a little light on these two massive cosmic puzzles.
Okay, first up, let's talk about dark matter. The best way to think about it is like an invisible cosmic glue. It's the hidden scaffolding that holds the universe together. But why do we even need it in the first place?
Well, here's the problem. When astronomers first started doing the math, they added up all the mass of the stars and the gas and the dust they could see in a galaxy, and the numbers didn't work, not even close. There just wasn't enough gravity to hold the galaxy together. The stars on the outer edges are moving so fast they should just be flung off into deep space. And that's the key. Without some extra invisible mass providing a whole lot more gravity, you wouldn't get these beautiful spiral galaxies we see. You just have a bunch of stars scattered randomly across the cosmos. So there has to be something else in there, mixed in with everything. Something that doesn't shine or reflect light, something dark.
So if it's invisible, how do we know it's there? We see it with gravity. You see, Einstein told us that really massive things bend the fabric of space-time, and that bend affects the path of light. And sure enough, when we look out into the universe, we see light from very distant galaxies being bent and distorted as it passes by huge invisible clumps of something. It's called gravitational lensing, and it's one of our best pieces of evidence that this stuff is real.
This is where the detective work gets really interesting. When you can't figure out what something is, sometimes the best you can do is start by figuring out everything it isn't. It's basically a giant cosmic process of elimination.
So what's on the ruled out list? Well, it can't be just big clouds of normal matter that haven't formed stars, because those would give off some kind of radiation we could detect. It's not antimatter, because if it were, it would be colliding with regular matter and creating a ton of very specific gamma rays we just don't see. And it's probably not a universe full of black holes, because its gravitational pull seems to be spread out smoothly, not concentrated in single points.
So after all that work, after decades of searching, we're left with three things we know for sure. 1, something is definitely out there. 2, it has gravity. And 3, there's an absolute ton of it. Beyond that, the trail pretty much goes cold. It's probably some new kind of particle that we've never seen before, but for now, it's a huge question mark.
Okay, so if you thought dark matter was weird, get ready for the other side of the coin, the even bigger piece of the puzzle, dark energy. It's the most dominant thing in the entire cosmos. And while dark matter is pulling everything together, this mysterious force is doing the exact opposite. It's pushing everything apart.
So here's the story. Back in 1929, Edwin Hubble figured out the universe is expanding. For the next 70 years, everyone just assumed gravity must be putting the brakes on that expansion. The big debate was, will it slow down forever, or will it eventually stop and collapse back in on itself? But then came 1998, and a total bombshell. Two teams of astronomers, by looking at distant supernova, discovered the expansion isn't slowing down at all. It's getting faster. This is a really mind-bending idea. It doesn't mean that galaxies are just flying away from each other through space. It means the fabric of space itself is stretching. Every single second, in every part of the universe, more space is being created, pushing everything further and further apart.
And whatever is causing this dark energy has to be unbelievably powerful. It's winning a cosmic tug-of-war against the combined gravity of every star and galaxy in the entire universe. And the weirdest part, as the universe gets bigger, the effect of dark energy just gets stronger.
So what could it possibly be? Honestly, we don't know. But there are some cool theories. One idea is that it's just a fundamental property of space itself, something Einstein actually came up with and called his cosmological constant. Another theory is that it comes from tiny virtual particles that are constantly popping in and out of existence in the vacuum of space. Or it could be some completely new kind of energy field that we just haven't even imagined yet.
So, where does that leave us? With a universe that's 95% unknown. And you know what? That puts us right on the bleeding edge of human knowledge. This isn't some failure of science. This is science. It's what exploring the frontier looks like, and it's incredibly exciting. The fact is, our best models for the vast majority of our own universe are, well, they're just theories. They're placeholders in our equations, names we've given to our own ignorance, waiting for the next big breakthrough to come along. I love this quote because it just nails our situation perfectly. No matter how clever we think we are fundamentally still in the early days of figuring this all out. We're just looking up at the sky, filled with questions and an incredible sense of wonder.
Look, it might seem a little frustrating that we know so little, but think about it another way. The map of reality is still 95% blank. That doesn't mean we failed. It means the biggest, most fundamental discoveries are still out there, waiting to be made. Discoveries that could completely change how we see everything. We get to live in an age where the greatest cosmic mysteries are still unsolved. And really, isn't that awesome?